Kia ora team, welcome to the video on prove, test, prove method for safe isolation. Let's get straight into it. Firstly, let's have a look at the equipment we're going to use today. You can see here I have a switchboard. I have a standard 10 amp socket, which is wired and connected to the switchboard. And I have my meter here. A couple of safety notes before we begin. This switchboard here is currently live. I have got this connected to power for the purposes of our demonstration today. This switchboard is not in a fit condition to be installed anywhere, and you would not expect to see a switchboard that looks quite like this in any building. This has been constructed for the purpose of the demonstration today. You can see we've got no covers on there or anything like that. I am an appropriately trained and qualified person who is authorized to carry out these kind of experimental things. Secondly, please don't take anything that we do in this video today to mean that if you watch it that you are competent to carry out any of these things. This video is intended for training purposes, to remind and refresh prove, test, prove method to people who are already undergoing some sort of electrical training. If you are sitting outside that space now and you are watching this video, please do not take anything I've said today and go and do anything like what I'm about to demonstrate. It's not safe. You need to be trained and qualified or supervised by somebody who is trained and qualified before you do anything like what we're about to do. If you're just watching for interest's sake, welcome along. Please try your best not to do anything like this, and you may hurt yourself. Okay, back to the action. This switchboard is currently live, as I said. I am going to carry out all of these tests in a safe manner to ensure that I am not hurt while we do this. If something goes wrong, this video might get very exciting very quickly. Stay tuned. Okay, so what we're looking for today is we're assuming that this socket here is connected to my switchboard, screwed to a wall somewhere in a building. And I want to work on that circuit. So I need to test this and make sure that it is dead. If it is not dead, I need to isolate it and then prove that it is dead before I carry out any work on this circuit. Obviously, in a real situation, the socket would not be sitting inside a switchboard like it is now. That's just, again, for experimental purposes in this video. In my switchboard here, I have a main switch. I have a supply coming in on my main switch. I have an RCD, a circuit breaker that's connected on that RCD, or 3 circuit breakers connected on that RCD, a second RCD, and a circuit breaker on this side, which is presumably connected on that RCD there. As I said, I want to work on this circuit. So what do I do first? Well, the first thing I'm going to do is check whether that socket is live. And I do that by plugging my meter into, well, we'll start with phase and neutral. And as I do that, you can see my meter is buzzing away, beeping, flashing lights, and it says 238 volts. So it's safe to assume this socket is currently live. You'll note that I've got the switch on the socket. If I switch the switch off, the meter goes dead. The circuit will appear to be dead. There's no point in me testing whether this socket is live if the switch is off. As I switch the switch back on, now it is reading a live voltage again. So we start with my socket is definitely live. So I need to find the appropriate circuit to turn it off. Now in this case, I don't know which one that is. So we will do that by process of elimination. But first, I'm going to start my prove, test, prove method. And our prove, test, prove method is first I must prove that my meter is working. If I were to test for voltage on the socket and my meter was faulty, it may give me an incorrect reading. In the worst case scenario, I have a live socket and my meter says that it is dead. So firstly, I must prove that my meter is working. Secondly, I test the thing which I am trying to isolate. And it should show that it is in fact isolated. If I've switched off the correct device, this should show that it is isolated. In order to make sure that that reading is correct and prove that my meter is still working, I go back and prove again. So prove my meter first, test the thing I've isolated, prove it again. How do I prove my meter? Well, I go to what we call a known supply. So that is where I have a voltage that is obviously not affected by switching this off. So in this case, I can use the mains coming in on my switchboard. So I can connect 1 meter lead here to the top of my main switch. I know that that is switched on, and I connect the other one to the neutral. And you can see we've got 230 volts. Proof that my meter is currently working. Now, to get your known source of supply, you may use the main switch in the switchboard. That's always good. If I haven't got my switchboard open, it may not be easily accessible. I could use another socket on a different circuit. Anything that I know is still switched on. Now I need to try and isolate this. Now, a quick one for me, because my meter's got a buzzer on it, this is very helpful. I'm going to plug that in here. It's currently showing that it's live, and now I can switch these switches off. Not that one. It appears to be this one. That is, I've switched that one off and my meter has gone dead. Now, to confirm that I have the correct isolation, I'm going to test between every pin on this socket to make absolutely sure that I've got the right one. So I'm currently testing phase and neutral. The meter says no voltage. I test between phase and earth. If it was live, I should see 230 volts. At the moment, I'm seeing 0. And I test between neutral and earth. I should get 0 volts here, whether it's live or not. And in fact, I am getting 0 volts. So I've confirmed phase to neutral, phase to earth, neutral to earth, that this socket is dead when this circuit breaker is switched off. To complete my prove, test, prove method, I go back to my known source of supply. Obviously, my known source of supply can't be connected to the same circuit breaker, otherwise it will also be off. In this case, I'm going to go back to my main switch and confirm again that my meter is still working. Why do I do this? Well, if something went wrong while I was doing this test and it exploded my meter, it may still be live. My meter is showing 0 because my meter is now broken, and I start working on the circuit while it is still live. So I prove my meter again to say, yes, it is still, in fact, working. So I'm just going to go again back to the top terminal on my main switch and onto my neutral bus bar, and we see once again that I have 230 volts, or in this case 238. That is proving that my meter is still working, and that's how we do prove, test, prove. Prove my meter works on a non-voltage. Test the thing that I'm isolating. In fact, we tested it and found the isolator while we did that, and then prove my meter again. Now, if I was actually going to carry out some work here, there is an additional step that I'll take, and we're not going to do now, but I'll describe it for you, is that I would lock this out. I'll put a lock on the circuit itself, with a clip on the circuit breaker that I can lock, and I put a tag on that with my name and contact details, so people can see they're unable to turn the circuit back on, and they can see who it is that's working on there. That tag will say danger on it to let people know, please don't turn this on. I am working on that circuit, and I'm going to have a bad day if you reliven it before I'm ready. Really, really important part of our safe isolation is to make sure we lock and tag our isolating device, in this case, the circuit breaker, after we've done our prove, test, prove, but before I disassemble the socket to do any work on it. That about covers it. This is a very simple and basic video outlining our prove, test, prove methodology. This is incredibly important. In fact, of all of our testing, this is probably the most important one, because this is the thing that will, on a day-to-day basis, keep you alive when you're working in the electrical industry. Prove, test, prove to ensure isolation, lock out and tag out to make sure nobody else turns it on. If you have any questions about this, throw them in the comments. I'm more than happy to engage with you and talk about it, and more than happy to have a conversation with anyone about this sort of stuff. Certainly better safe than sorry. If you are uncertain about any of these things, you can seeking guidance is clearly the best course of action. All right, stay tuned for more videos in our series. thanks for stopping by. I appreciate it.